good evening for all my fine EL 115 electrical mathematics students. This is Scott Sexton. This will be the first video on our adventure that we have today, going forward in the next 6 weeks. There'll be one or two videos every week that we'll be doing, working over some calculations and whatnot. This video, I wanted to kind of take a little time to introduce myself and talk to you about how to approach these calculations. And I'm going to talk a little bit about it, and then I've got one of my contributors that we use, uh, outside source, that we're going to run a little video for him. He's got about 10 minutes or so long, and he gives a really good explanation on where we derive how it is that we use particular codes for the calculations. And this is all about the 31016 chart, where we have the ampacities of the wires themselves, and you have a 60, a 75, and a 90-degree chart. And he goes into great detail and gives us code references. And I want you guys to all write down the code references that he's given. It's a 110 series. It's in the very beginning of the book. And it affects how it is that we do these calculations when we're doing load calculations. But before we get started, uh, I just wanted to say, man, I'm glad to be here. I'm glad to see everybody. Glad that everybody's taking the time to be able to get into the trade. It's glad to see that I'm just not going to retire and it's all going to go away. I've been doing this for 25 plus years. I've been teaching guys how to pass the journeyman's test since I became a journeyman and before. I got my first journeyman's license in 2001 and have had a master's license or a journeyman's license since then. I done retirement back in 19, came out of the field fully. Actually, it was in 18. Uh, been doing project management and estimating in field operations since about 2010. Had an accident in 2012 that kind of took me out of the game for a little bit. I had to do some physical rehab to be able to get back into it. But as you can see, I've got this gray hair, and I'm getting older, so I've got to kind of step out of the way and let you young whippersnappers, as it was, take over. So I've seen a lot of changes in the trade. I've seen a lot of things where they're, getting away from some things and going towards better things. It's always changing. And one thing as an electrician you need to know is you need to be Gumby. You need to be able to adapt and overcome it. Don't be rigid in anything other than the quality of your install and your integrity. Those things I want you to stay rigid at. So, without further ado, we're going to move forward with our video about the calculations. So what I want you to do is I want you to get your code book out and follow along, and you can stop my video at any time and look at the code references that we're discussing, and look at the references that we're calling out in the video. During the video, there will be a few quiz questions that'll pop up. Do complete the quiz videos and complete the full video and the quiz and submit them at the end. That way you get credit for the entire thing. Okay. With that being said, let's kind of roll back over here to old Mr. Mike Holt. Mike Holt, take it away.
Code calculations. It comes both as a standalone book, which has only those rules, or it comes with the Understanding the NEC library, which the rules are already contained in here, but the videos will be reflective in this program as
So don't worry about the book itself that he's talking about. I want you to just worry about the ideas behind it. We're looking at changing the curriculum potentially. This is one of the options. And I've used this guy off and on for a long time.
as well. All right. First thing we want to do is move into Article 110, General Requirements for Installations. And we're going to move to 110.14, which is conductor terminations. Now, what I'd like you to do is, like all I program, it's important that you have your code book as we go along. You should be highlighting. Maybe it should be tabbed, depending upon, most people tab it. You might have a ruler, pen, pencil, markers, and then you can identify those rules that we're covering in here. All right, let's go to the first rule, 110.14c. 110.
Now, what he said about this, the rulers, in the class, I teach everyone how to make their own tool. And we do it in every one of my classes. I use a folded piece of paper to be able to keep track of where I'm at in the code, along with in the charts. You'll see them using a ruler. You can't take a ruler into the code whenever into the test. When you take the test, all you can do is take your code book. You can't even take a calculator in. So, getting used to just taking a piece of paper and folding it up, turning it into a ruler, that way it's a good straight edge, is a very good habit to have.
110.14c says this: unless equipment is listed and marked otherwise, conductors are sized based on table 310.16 in accordance with A or B as follows. I'm not going to get into the details of A or B, but let me just do a general conversation. 110.14c1a says that if it's 100 amps or less, meaning a circuit 100 amps or less, or 1 gauge wire or less, that we're going to be sizing the wire to the equipment manufacturer's terminal ratings of 60 degrees C. Like, I don't know what you're talking about. Don't worry about it. Just relax. It also says in 110.14c1a, there's another little subcategory. It says, well, you know what? You could put a bigger wire, you could put a higher insulated wire than 60 degrees C, but then you still have to size the wire to 60 degrees C. And then it goes on even a little further and it says, well, okay, wait a minute. 110.14c1a has another thing saying, you know what? If the manufacturer has their product listed for a higher temperature rated equipment, then you can use the higher. So what is the practice today? The practice today is that terminals are rated for 75 degrees C. And you're probably thinking, I don't even know what you're talking about. All right, fine. Brian, let's go to table 310.16 in the National Electrical Code, which is going to be conductor ampacities. So obviously that's what I'm looking for everybody to do. So we go to 310.16 in the code, and there should be a tab right there. I get my tab. And when you get to table 310.16, what I need you to do is, I need you to highlight the 75 degree C column. Copper. What about aluminum? Fine, if you want to highlight it, I don't really care. But it's copper or aluminum. You're going to highlight the 75 degree C column because that is in the real world how you're going to size the wires. I know what you're talking about. Don't worry about it. Just highlight the 75 degree C column all the way down for copper. And what I would do is highlight the word copper. It's in the top of the table there, so you know it's there. Then I would go over to aluminum, and I'd highlight aluminum. Then I'd highlight the 75 degree C column for aluminum. And then that would be how I'm going to size the wire. But Mike, I thought you said it was 75. I thought you said it was 60 degrees C. Well, it's 60 degrees C unless a manufacturer has their products listed for other than 60 degrees C, and they do. And you can just see on the product, you'll see on it, they'll have the temperature ratings marked on the product. Okay, so now, what's a 60 degree C column for? And what's a 90 degree C column for? So I would go to table 310.16 on the 60 degree C column. I would put on there Romex. I would write on there Romex or NM cable. So whenever you use an NM cable, I would go to the 60 degree C column. Mario, what is the code section that says NM cable has to be sized to the 60 degree C column?
That would be 334.80.
Right. So we're going to talk about that later, but now, what about the 90 degree C column? Well, the 90 degree C column is going to be highlighted, and we're going to be using that anytime we make an adjustment. So I'm not going to even do anything with the 90 degree C column right now. We're going to do it on a unique case. We're not worried about it now. Let's go back to the slide. All right. Unless equipment is listed and marked otherwise, conductors are sized based upon table 31060 and equipment A and B. So, going to the first graphic, 110.14C1A3 is the rule that says that this is 100 amps or less, which should be sized to 60 degrees C. But since this equipment is rated 75, and since this breaker is rated 75, and since this wire is run in between these 2 points, then I size the wire to a column of table 31016. And since this is rated 75 and that's rated 70,
It's almost all Greek. I realize that. Okay. In the end, this code has been updated several different times over the years. The minimum standard that you need to have is the 60-degree column, like you said, whenever you're talking about the wire itself based on the code, equipment 100 amps or less. But because you're connecting to multiple pieces of equipment that are rated 75, okay, you're able to actually use that 75-degree chart. And that is my go-to, unless I'm doing something really squirrely. But 75 degree is what I use. And what we're talking about in the NEC code, we're talking about in 31016. This, as you can see here, this is rated at 75 degrees. The breaker itself is rated 75 degrees. And they're talking about using the 31016, okay, column to be able to say, hey, this is the size of the wire. Well, Scott, you asked me, what does this have to do with calculations? There's no math in this. I'm just looking something up. Yep, you're right. There's not always math, but understanding because all of the math that we do is all about getting the right size of wire. That's the whole reason we do it. The whole reason we do it is to be able to make sure we don't burn anything down, and be able to do that is we make sure we get good grounding and the right size of wires and good connections. And it's kind of like I've told a lot of the students, we are building a layer cake. And this layer cake it's got a lot of pieces and parts to it. And it's the basis, and you're working on the basis, and we're going to work our way up from the basis. Okay, so just be calm, soldier on, and don't let this be overwhelming. We will work through this, and we will get through it.
75, I go to table 31016. And if I have a 50 amp breaker, and let's assume I need a wire that's rated 50 amps, then go to your table 31016. Go ahead and do it right now. You're going to go to 75 degree C column. That's what you highlight. Let's go with copper, unless I tell you otherwise. That's going to be 8 gauge. You know the breaker. There's right there. And then you go to table 31016, 75 degree C, and you size your wire. Hey, listen, I need you to run a 100 amp circuit out there. Well, if you can run a 100 amp circuit, that's 100 amp circuit. 100 amp circuit. Well, if I have a 100 amp circuit, I go to table 31016, go to 75 degree C column, go across the line, and that's going to be a 3 gauge wire. This is not complicated yet. It's going to get worse. But the first thing I want you to know is, when you go to table 31016, what column do you use? You use the 75 degree C column. Somebody's going to tell you, no, there's a code rule that says you have to go to 60 degree C. Now, this can be a problem in my book. Because if I don't tell you to use that the equipment is rated for 75 degree C conductor sizing, then you'd have, and if it's 100 amps or less, then you're going to have to go to the 60 degree C column. So if you're taking my program, you'll notice that, Mario,
Now, I want to point something out of what he just said. If the question itself that you're given doesn't reference equipment rating temperatures, and it's 100 amps or less, you've got to use the 60 degree column to be able to size your wires. Again, if the question doesn't call it out that, hey, I need to have, or if your question doesn't call out and say, hey, this piece of equipment's rated for 75, 60, 90, if it doesn't call it out, you've got to make the assumption that for the lowest and most protection on the 60 degree chart, and if it's over 100 amps, you go ahead and go to 75. But if it's 100, you'd use the 60 degree chart. Man, it's just a tongue tie. I get tied up with this with the words every time on this. I get excited because this part of it challenges my brain to be able to keep up with it. So less than 100 amps, or if it's NM cable, that's going to be a 60-degree chart. If it's over 100 amps, then it'll be 75. If they don't say anything about what your equipment rating is what then you use what we just talked about. If the equipment says it's rated for more than that, you base your wire sizing and wire temperature ratings on the equipment itself.
We're always consistent when we want them to use the 75-degree C column because we will always say, you know,
Terminals are
equipment
marked 75 degrees
is
C.
rated for 75-degree C conductor sizing. If we don't say that, and it is 100 amps or less, then you have to go to the rule. And the rule, again, this is using papers. This is not in the real world, but if it's in a question in a course, so you got to be real careful that you will always use 60-degree C column size for conductor sizing in my textbook if it's 100 amps or less. But in the real world, you're going to use the 75-degree C column because all equipment meets this requirement here of 11014C1A3, which are rated 75 degrees C. Okay, let's go to another example.
Now, do you hear what he said there? He says in the courses, depending on how the question reads, okay, you'll have to make that determination whether you're using 60 or 75. But in the real world, all equipment is rated 75. So as a standard rule, I use everything setting at 75 degrees.
Column because all equipment meets this requirement here of 11014C1A3, which are rated 75 degrees C. Okay, let's go to another example. Now, this is 11014C1B2.
11014C1B2. Boy, that's a mouthful, isn't it?
You're good. You can start back on that slide. All the buttons froze up.
Okay, you know, I went from this slide to this slide, and what changed was really important is right here. Let's go back here. 11014C1A3 says 100 amps or less. If the equipment is rated other than 60 degrees C, then you size it. Well, then we're going to size it to 75 because they're marked 75. 11014C1B2 says if it's over 100 amperes, then the terminals are to be sized based on 75 degrees C. So that's kind of convenient that if they make them 75, 100 amps or less, and if they're over 100 amperes, they make them 75. And in the real world, we go to 75 degrees C column to size the conductor for that equipment. What are we even talking about? We're talking about right here, these terminals for this equipment, that this equipment terminals had a 75 degrees C conductor size on there when they did the testing. So 90 degrees C would give you a higher ampacity. If you go to the 90 degrees C column, it would give you a higher ampacity, but the equipment was not designed to operate at high temperature because the 90 degrees C wire was smaller. But the equipment was sized based upon the 75 degrees C column. So we're just simply complying with the way the product was intended to be installed. It's intended to be installed with conductors sized to the 75 degrees C column. That's all we're talking about. So going back over to this graphic here, if it's a 200 amp breaker, I get to my code book, 31016, 75 degrees C column, looks like it's 3-aught. That's the wire. So it's not that complicated. Now, it's a little more complicated when we go to size the breaker or size the circuit, but if they tell you, now what I did when I was an electrician and I was learning this material, I would go to the plans and I would look at all the plans and they would show you the breaker size and the wire size, and I would check every single one. And you know, sometimes people make mistakes. You know, so that's just something, give me my exercise. All right, let's move on. Here's another example. Who's it? Oh, this is aluminum. Well, we go to the 75 degrees C column. right, John?
Yes, sir.
And what size wire would that be for aluminum?
You looking for 200 amps, sir?
200 amp. I have a 200 amp breaker or feeder.
And you're looking at a 75-degree column for aluminum. That would be a size 250 KC mil.
There you go. And that's how we worked that out. So, and it's kind of fun. I kind of enjoyed this because it's kind of fun when you, I don't know, it's fulfilling when you have tables and you look them all up and you kind of go that way, Brian?
Yeah, a couple comments, just as we're kind of getting started here. So you notice John's using a ruler. It's very important on tables, especially in your code book. You're probably at some point in your career, if you're watching this video, that you might be taking an exam in your future. And you want to build good study habits now. So along with the highlighting, you want to be getting accustomed to using a ruler or a straight edge of some sort to make sure you get the right answer on the table. The other thing just to be aware of, if you are taking your test at some point in the future, find out if your state allows you to write in your book. Some states do not allow you to write. Almost every state allows you to highlight. There are a couple that don't. Almost every state allows you to tab as long as they're permanent tabs. But not every state allows you to write. So just find out what your state's requirements are. You may want to, and what I would do is I would just write and highlight and tab and all kind of stuff while I'm studying.
Yep.
And then at whatever point in time you go, hey, in about 6 months, I'm going to take my exam, I would get a brand new code book and I would prepare that code book based on, we actually have a video on that during the exam prep. Based on that video, I would prepare your code book specifically for the exam. It refreshes you on where everything is at. It makes your highlighting more consistent, cleans everything up. Your tabbing is going to be better the second time you tab it. It's going to cost you an extra $150, $200. But this is possibly the difference between passing your exam the first time and not passing your exam the first time.
All right, so let me repeat what he said. Make sure your code book, tabbed, marked, highlight, underline, put asterisks, corners, stars, put arrows, write anything you want to write in your book, that this is your tool. One day, maybe it's the same code cycle, the same book, or it's going to be another code cycle. When you get ready to take a test, you're going to be taking a program on how to prepare and pass an exam. At that point, you listen to us. Just do what we tell you to do, and you're going to smoke the exam. Mario.
Yeah, I just want to add that this rule here, 110.14C1, it sets the foundation to always, what we're talking about here within the scope of this program, to always go to that 75-degree C column with whatever you're doing within the scope of this program. So this rule here sets that foundation.
Okay, now there's a note here on this particular graphic. It says conductors rated 90 degrees C can be used. In other words, if I put on here THWN-2, which would be a 90 degrees C, you can use 90 degrees C insulated conductors. But because the equipment is rated for 75 degrees C conductor sizing, we go to the 75 degrees C column of table 31016.
You know, Mike, funny little story about that, and I think this will really hit home with a lot of the people watching this video. Not when THWN-2 first came out, but when it first became very readily available on the shelves. And this was probably late 80s or early 90s in our part of the country where they started stocking it. And people started teaching on it. And maybe it had even been around and nobody was teaching on it yet. And I found out about it. And I was like, oh yeah, 90 degree. Wait, hold on. You mean I can use these wires for XYZ amperage, which was far different than, you know, what I was accustomed to using it for, because the 90 degree column actually has a much higher ampacity than the 75. I wasn't aware of this 11014 at all.
You know why?
No.
Anybody know why he wasn't aware of it?
No one taught him.
No.
No.
It wasn't in the code.
Really?
It was in the product standard.
It was in the standards.
And so what happened was people were saying these guys are not reading the product instructions. So what we need to do is we need to take the product instructions and we need to put it in the code book so people would understand. Now, this wasn't a problem because we didn't have 90 degree C wire. But once we got 90 degree C wire and we're all out there running 90 degree C conductor sizing, which was too small, we didn't know, but the equipment wasn't rated for that. That's why you would have never have known that. Then they brought in 11014C to remind people, listen, you can't go to the 90 degree C column to size conductors to equipment. you got to go to the equipment. And so the general rule was this when it came out 100 amps or less was rated for 60 degrees C. There was no conversation about allowing you to use a larger insulated, an adjusted temperature. So when they came out with this rule now you found out you not only cannot use the 90 degrees C, if it's 100 amps or less, you had to go to the 60 degrees C that you were screwing up already because you were using the 75 degrees
Oh, yeah,
C.
definitely.
Okay?
Definitely.
And then once they did that, 100 amps and above, you can use the 75 degrees C. Well, the problem was that manufacturers, they just ran the test to 75 degrees C and nothing changed.
Right.
Then they marked it 75 degrees C. You know what I'm saying?
Yep.
And then we had the rule that says, well, you know, it has to be 60 degrees C conductor sizing, 100 amps or less, unless the equipment is marked otherwise. So now all equipment is marked for 75 degrees C. So mechanically nothing changed.
Right.
But it wasn't until we got the 90 degrees C that we found out you can't do that. And then they brought the rule. That's why you would not have known that.
All I know is when that THWN came out, buddy, I was using that 90-degree column all over the
Me
place.
too.
And then
I was there when it came out.
I got corrected
I was there when it came out.
by actually a good friend of mine who was an inspector. And he failed my entire job. And I got to repull all the wire.
Listen,
Everything was the wrong size.
you can't screw your friends. I mean, come on.
I mean,
seriously.
like, yeah, no, hey.
I mean, right there is the best part.
And I just want to emphasize the key word Mike is using is equipment. So you will maybe run across a scenario where you have equipment with 90 degree C terminals in it, but the equipment itself is still rated for 75 degrees C.
And we're not looking at the lugs to see what the lugs are rated, because lugs are commonly rated 90 degrees C, and the lug guys sell it to everybody. And then the lug guy sells it to everybody, and that guy who's everybody gets it, puts it on as an equipment, and some guy looks at the terminal and said, oh man, that's rated 90 degrees C, I can size wire. No. The equipment had that lug was only rated. So it's 75 degrees C in the real world, but if it's in our books, unless it's identified otherwise, you're taking a test, it's 60 degrees C if it's 100 amps or less. Over 100 amps, it's going to be 75.
So a quick search, it looks like 1993 is when 11014C came into the NEC.
But not that long ago. I mean, you know, but I mean, it all depends on your career.
Yeah.
Those are a group of some very wise and experienced men. Mr. Mike Holt there, with the guy that's kind of leading the group, he is the go-to for a lot of inspectors, a lot of trainers, a lot of electricians. Do take the time to be able to watch this video again if you need to. Do reference the code references that we used in here. There will be a quiz that gets posted with this. I appreciate everyone's time. Seems like it's a little dry, but as electricians, we get excited about some of these things. You'll end up loving it. You'll end up enjoying this part. Some of you already do if you got that type of mindset. Some people won't. But here we are. We're at the end of this video. I appreciate everyone's time. I look forward to the next video. I look forward to a discussion question about this video. I will post one beginning of the mod, probably Monday evening. And I'd like to be able to hear your responses about what you have been able to understand through this. And in the end, we're just making sure we get the right size of wire to be able to carry the load. That's it. Very simple. Being safe. Getting wire to where it needs to be going. As electricians, we wire the world. Team, thank you very much. Look forward to it.